Hey everybody. So today we're going to get into the math again of consumer math, but we're going to make sure that it fits with what we're learning about checking accounts right now. So don't panic, all will be well. I'm going to walk you through every step. Here we go. So what I would like you to do first is, with the people you're sitting with, read through the beginning of this lesson. And it's all about this Hart family buying their pretzels. And I would like you to answer questions 1, 2, and 3 together. And we're going to pause the video. And when you're all ready, we'll begin again and see what we think. Okay, so here we are. We have the situation with the number of lunches we are getting made and how many pretzels that is taking. So here's what we need to be thinking about. When we're going from the number of lunches made, like for example, let's say I'm going from 3 to 7 lunches. So that's an increase of 4, right? So what's happening with the pretzels remaining? Well, I'm going from 378 to 306. So my pretzels are going down by 72. So thinking about that, the number of lunches went up by 4. So we made 4 lunches and somehow 72 pretzels got used. So if we're trying to think about how many pretzels went into every lunch, we could say, well, these 72 pretzels went into 4 lunches. So what must have happened? Well, 72 divided by 4, you can get your calculator out, and that is 18. So we have figured out just by looking at 2 lines of this table that to make 4 lunches, we use 72 pretzels, and 72 divided by 4 is 18. So there we go. Now you might say, well, why did you use 3 and 7? Well, I didn't have to. Let's check it out. If I had gone from 7 to 9 lunches, that's an increase of 2 lunches, right? Well, I'm going from 306 to 270. So that means I used up another 36 pretzels to make 2 lunches. So I also could have said, well, what's 36 divided by 2? Again, it's 18. That's the cool thing about this, right? Is that it really doesn't matter which 2 things you ever look at, you're always going to get 18. In fact, I could say, what if I went from 3 to 13? So that is an increase of 10 lunches I made. And what happened here? Well, we went from 378 to 198. So we use 180 pretzels. So 180 pretzels divided by those 10 lunches, again, gives me 18. So that's the beautiful thing about linear equations, is no matter what 2 situations you decide to compare, you are always going to get this same rate of change. Okay, so now we're going to use this to predict. So we know that every single lunch, we're getting 18 pretzels in a lunch. So let's say he's made 16 lunches. That means 3 more lunches than where he was here at the end. He was at 13 lunches, right? So 3 more lunches. So he is going to have to do his 18 3 more times. And what does that make? That makes 54 he's going to use to make these 3 more lunches. Well, he only had 198 to start with, and now he's used up 54 of them. So what does he have left? He has 144 left. So I know when you've learned about linear equations before, it never really seemed like it was tied to anything. And in this class, we want to always tie it to something real. So don't worry about using formulas and X's and Y's. Just try to think through the situation. So now my question is, so how many did we start with? Interesting. We know what's going on, and eventually we're going to run out of pretzels. But let's go back in time. How do we do this? So we know we started with 3 lunches already made, right? And we had 378 pretzels remaining. And we also know that if we are going backwards, we're going to have more pretzels, right? Because we started with more and then we kept putting them in these lunches. So let's go backwards. So at 3, we had 378 pretzels. If I had only made 2 lunches, I would have 18 more pretzels than I do. So that would be 396. So I would have then had 396. And if I had only made one lunch, that would be another 18. So I would then be at 414. And so what if I had made no lunches at all? Well, add another 18 on, and I would have been at 432 pretzels. So what I would like you to do now that we've kind of gotten an idea of this rate of change that is happening with these lunches and these pretzels, I would like you to go to the rest of the page and answer questions 4, 5, and 6. And then we're going to pause again. Okay, so the next question is, how many servings can he pack with one tub of pretzels? So we said at the beginning he had 432 pretzels, and we know he is using 18, right? So let's think about this. So he has 432 pretzels total to begin, and he is going to use 18 in every single one. So if we thought about 432 divided by 18, what would that give us? I mean, let's think about that for a sec. So get your calculator out, and we're going to figure out 432 divided by 18, and we end up with 24. So he can make a total of 24 lunches with his tub of pretzels. That's pretty cool. So we're going to now write an equation, and we're going to think about the number of pretzels that are left. But as we do that, I want to go back to the first 3 questions again and highlight what's important. So what's important are, first of all, how many did we start with? So I'm going to put some stars next to that. That's pretty important because we are starting with 432. The other thing that's important is how many pretzels are we using every single time we make a lunch? We're using 18. So my equation is going to be this. We're going to start with our 432, and we are going to subtract 18 times L. Every lunch gets 18 pretzels. And so if I'm thinking about graphing this, I'm going to be starting at 432, which is right about here. And I also already know he's going to be out of pretzels after 24 lunches. So when we get to 24 lunches, and this x-axis is now our L-axis for lunches, he's going to be out. So we know all the important things. We know what he starts with. These are his pretzels. And we know how many lunches he's going to make when he's out of pretzels. And we're just going to connect those two. And you have just graphed your line. Now, in terms of algebra talk, we would call 432 the y-intercept. And we would call negative 18 the slope. But really, it was just what did we start with and how many pretzels did we use each time. So what we notice when we label our x and y intercepts, we are at 24, 0. That's how many lunches we made when we ran out of pretzels. And on the y-axis, or the p-axis, I should say, we are at 0, 4, 32. And that's how many pretzels we started with. So let's go to the next page and do a little summary of what we have just learned. So I'm going to go ahead and write that formula we all learned a while back, y equals mx plus b, and we're going to talk about what is important to remember about that formula. First thing, this b, the number that does not have the x, that is your starting amount. And that's also going to be where you are on the y-axis, or whatever the vertical axis is all about. The m is telling us our rate of change. How much does this change as we move forward in this situation? You might remember this as a rise over run. And if you remember that, that's great. But really, the easiest way to graph a linear equation like this is to say, all right, well, I know that b is my y-intercept, so that's going to be here. And then somewhere, this line is going to be hitting the x-intercept, or the horizontal axis. If you can figure out where that is, like we figured out how many lunches will use up all the pretzels, you don't really have to worry about rise over run at all. You can just connect the two, and you will have your answer. So when we're talking about checking accounts and we're thinking about growing money and also losing money, this is going to be making a line, and that's what we're going to learn here. So what I'd like you to do now is go to the Check Your Understanding and work through these questions, and just go ahead and pause the video. And when you're ready, we will talk through some of these so you kind of get an idea of what you're going to do for homework. Okay, so question number 1 is about an ice skating rink. And I see that we are being charged $4 per hour. Okay, so let's kind of pay attention to this. $4 per hour, doesn't that seem like a rate? And it is. So I'm guessing this $4 per hour might end up being my slope. So whenever you are given a rate, that's your slope. Okay, we have the option to rent skates for an additional cost. So Marlo paid $13 to rent skates and to skate for 2.5 hours. So can we figure out the cost of renting skates? Well, let's see. So we know that it's $4 per hour. So let's say that we have 4 times some hours. In fact, no, let's not even call it X. Let's call it H. So 4 times H. Don't know how many hours it was, but that's okay. Oh, wait, back up. Yes, we do. We see that we are skating for 2.5 hours. So we can go back and say, wait, no, we know what we're doing here. It's $4. $4 times 2.5 hours. So we know how long he was skating. Now, we also know there was this fee to rent. Let's call that R. And he ends up paying $13 total. So can we figure out what's going on here? Well, 2.5 times 4 is going to give us 10, right? So we have 10 plus R is making him pay $13. So what does R have to be? Well, it's got to be 3. And we're talking about money. So $3 to rent. Cool. So now let's see if we can use that to answer part B. So part B wants to know how much would it cost to rent skates and be on the ice for 4 hours. So our cost is going to be renting the skates. We already know that's $3. And we know that we are on the ice for 4 hours and it costs $4 per hour. So we have 3 plus 16 for a total of $19. The important thing when you do problems like this is that you are showing your work as you go along. Okay, on to the next question. So we have Nico drinking his shake at a constant rate. After drinking the shake for 3 minutes, there are 14 ounces of shake left in the cup. And after 9 minutes, the cup is empty. Okay, so we know that after 3 minutes, we are at 14. So this information right here, that's a point. 3:14. So let's go on to our graph and graph 3:14. There we go. We also see that after 9 minutes, the cup is empty. So after 9 minutes, we got nothing. So here is the point at 9:0. So could we connect these points? Well, of course we could, right? And so what we're going to think about here is what would an equation look like for what the line that I'm about to draw. So let's go ahead and connect these points and just see what happens. Okay, so here we go. So it says we're going to write an equation for the ounces of shake left after T minutes. All right, so what I would like to do is to get a little more exact. So let's do what we did back at the beginning when we were thinking about the pretzels. When we go from 3 to 9 minutes, so 3 to 9 minutes, what we are doing is increasing our time by 6 minutes, right? But our ounces are going from 14 to 0. So we just lost 14 ounces in those 6 minutes. So what kind of change is happening? Well, we lost 14 ounces in those 6 minutes. So negative 14 over 6. And if I reduce that, I have negative 7 over 3. That's my rate. Okay, so I know that my rate is negative 7 over 3. Okay, cool. So that also means if I were to go from this point at 314, and if I were to go up 7 and left 3, I would be at my next point. So let's think about this. So I'm at 14. If I go up 7, that takes me to 21, and then left 3, I just landed at the y-axis. I am at 0, 21. That's my starting amount. So I have figured out what I started with. So my equation will be my starting amount, which was 21, and then it looks like I am drinking 7/3 of an ounce every minute. So I'm going to call that X. And if you want to use letters that make sense and say something like S equals 21 minus 7/3T, that's totally fine. You can use whatever letters make sense. But as always, we start with how much do we have at the beginning, and then we think about how much are we losing every time a minute goes by. So what are our X and Y intercepts? Well, definitely 0.21 is my starting ounces. This is what I had at the beginning, and there we go. And then this one here at 90, that is how much time it took to drink the whole thing. So now that you have worked through these example problems, let's go on to number 3. This is our third one. So Kara is using a video service provided by the cable company. We have an initial cost, and the table below shows that the amount of money it's going to cost her in each of the last 3 months. Okay, so again, let's think about what's happening. So if I go from 4 movies to 2 movies, what just happened? I increased my movies by 2. What happened to my cost? I didn't increase. Sorry, I decreased my amount by 2. So let's do that, right? So 2 less movies, and my price went down by 4. So 2 less movies, my price went down by 4. So I lost $4 when I lost 2 movies. So guess what? The cost of every movie is $2. That's right. So $2 per movie. I just found my rate of change. Okay, cool. So what would that cost if we didn't have any movies at all? So let's think about that. I'm going to make my little table here. So 4 movies, 16, 2 movies, 10. What about if I had no movies at all? Well, following the pattern, if I take away another 6, I'm at 4. So 4 is what you have to pay for the video service, and then you're paying $2 a movie. So we have just figured out the cost it is if you rent no movies. It's going to be $4. And we figured out that every movie costs 2. Can we write an equation for this? Of course we can. So here we go. So our cost is going to be the $4 you pay up front, plus you are paying 2 for every movie. So 4 plus 2M. Okay, so now if we go to the homework, so you're going to be getting a homework packet. We're going to walk through a few problems together just so that you know what you're doing. So the first questions are going to ask, what is the slope and the initial value? So when I look at my first equation here, the important thing to remember is that slope is always attached to a variable. So I see there's a -5 attached to that x. That's my slope. The other number, the 12, that's my starting amount. So I'm starting at 12, and I'm losing 5 of whatever it is every time another minute or whatever goes by. Okay, so that's how you do the first problem. Now let's go to number 2. So here we have a bunch of equations and a bunch of tables, and we're going to try to figure out what's going on. So let's label it just like we did with the pretzels, okay? So here we go. So if I go down from 0 to 2, I just went up by 2. That's my inputs. But on the second column, I went from 5 to 8. I just went up by 3. So I know my slope is 3/2. It's always the y over the x, right? That's my rate of change. So right now I can already tell either the answer is C or D, because both of them have a slope of 3 over 2. The other thing I have to figure out is what am I starting with? So when I look here at 0, I'm at 5. So my starting amount is going to be 5. And that means D must be my answer because that is the equation that has a slope of 3 over 2 and a starting amount of 5. So that's how those work. Now let's go to number 3. So our situation now is about Ahmad. He has $112 in his checking account. What is that? Well, that's what he's starting with. So that is his start, right? So that is the start. And then it says he earns $75 per week. That is his rate or his slope, how fast things are changing. So initial value is going to be 112. The slope is 75, and he's adding that to his account. So he's adding. So if we wanted to make a table, we could say, okay, at time 0, he's at 112. When 1 week has gone by, we're going to add 75 to that. So now we're going to be at 187. If another week goes by, we can add another 75 and then add another 75. So getting our calculators out, if we're at 187 and we add 75, we are now at 262. And if we add 75 again, we are at 337. So our checking account is growing. Can we write an equation for this? Sure we can. So we will say, all right, we're starting with 112 and we are adding 75 every week. So 75x. So now the question is, so what happens if a year goes by? Well, we're going to use our equation now to say, well, I know x is how many weeks are happening. So we are just going to do our 112, and then he is going to increase his 75 52 times. What happens? Well, let's find out. So 75 times 52 plus the 112 he started with. And he has a whopping, wow, $4,012 in the bank. Awesome. So that covers the front page of your packet. There are 2 more pages for you to do, and I will see you next time, and we will go over all the answers. I hope you found this pretty easy. Have a good day, everybody.